discuss the Larmor precession, which is in continuation with the vector model of atom, and as we have already discussed in the previous video about the magnetic moment and orbital angular momentum of an electron revolving around the nucleus in any circular orbit. Here also, this is the electron revolving around the nucleus in circular orbit of radius r with velocity v, such that its orbital angular momentum, which is directed perpendicular to the direction of velocity as well as radius vector, so the angular momentum is directed along this direction. Suppose this system, this electron has been kept in a magnetic field directed along z axis, such that the orbital angular momentum L of this electron makes an angle of theta with the magnetic field. Due to the presence of magnetic field and the electron revolving around the nucleus, which is behaving like a bar magnet, experiences a torque, and the torque is given as, if mu L is the magnetic moment and B is the magnetic field, then torque tau is given as mu L into B. That is equal to mu L cross B or mu L into B into sine theta, right? This is the torque experienced by this electron. Due to this electron experiencing the torque tau, the orbital angular momentum of this electron, this axis, starts precessing. This is the axis of the electron. This axis starts precessing about the field B, which is directed towards the z direction, with a radius of L sine theta. If this is making an angle of theta with the magnetic field, then this will be the L sine theta radius on which the orbital angular momentum is tip of the angular momentum. This is the tip of the angular momentum. This tip of angular momentum starts precessing about this field. This precession of angular momentum along the field direction, about the field direction, is called as Larmor's precession. Let in time dt, it moves from position A to position B, making an arc of dl subtending an angle d theta. Then you know that d theta, angle d theta is equal to arc dl upon radius, that is L sine theta. So d theta is equal to dl upon L sine theta. Right. This is d theta is equal to dl upon L sine theta. Now, as you can say that d theta is equal to omega into dt, where omega is the angular precession frequency. So omega, the precessional frequency with which this tip of the angular momentum is precessing about z axis. So d theta is equal to omega dt, or omega dt is equal to dl upon L sine theta, or omega is equal to dl upon dt into 1 upon L sine theta. Now dl upon dt, this is equation number 4. dl upon dt is what? This is the rate of change of angular momentum. So rate of change of angular momentum is equal to tau, torque, tau. So omega is equal to tau upon L sine theta. Tau from equation number 1 is mu L into B sine theta. So omega is equal to mu L into B sine theta upon L sine theta. This cancels out. So omega is equal to omega comes out to be how much? Mu L upon L into B, right? This is equation number 7. Omega is equal to mu L upon L into B. Now omega is equal to 2 pi f, where f is the Larmor frequency. So f Larmor frequency can be written as equal to omega upon 2 pi, and this is equal to 1 upon 2 pi into mu L upon L into B, right? Mu L upon L into B. Now mu L upon L is nothing, as you know, relation between mu L upon L is E upon 2m. So putting this value, we get mu L upon L is equal to E upon 2m. So F is equal to 1 upon 2 pi into E upon 2m into B, or F is equal to EB upon 4 pi m. This is the Larmor frequency.